All right. Thanks, everyone, for attending. I know there wasn't another track, so you didn't really have much of a choice, but still appreciated. So as mentioned, I'm Travis Cline. Online, I go by TMC. That's my handle on GitHub. And I created this project I'm going to be talking about today called LangChainGo. It's actually highlighted in Cameron's talk this morning, which I think set the stage quite well. So what am I going to go over today? So high level, I know we only had a couple hands for folks that use AI. I'm guessing if you in-scope Copilot, it would be more than the 1% I saw. Can we just redo that? How many of you use AI while editing code? Okay, that's like 90%. Okay, that's what I thought. And the other 10%, I hope we're just working on the X-risk stuff directly, right? Okay, so I'm going to go over like high level what's happening in the generative AI space, where Go fits in it today, and where Go might fit into it. So again, be a little callback to Cameron's talk this morning, as I think it was very prescient with regard to this topic. So I'll talk about LangChainGo. I'll show some hopefully live coding demos. If my ability to get the monitor working is any sign, they'll all go very, very well. And then I'll close out talking about like where I see Go going in the future, and perhaps I'll be able to convince you to get involved yourself. So who am I? I've been doing open source contribution for a very, very, very long time. My very first open source, funny story, I was working at a Python shop, and I was trying to get Python to go into places that it probably didn't fit in very well. So I won't point out the project, but you can go find it on GitHub. It was a little compatibility system between two event loops, so I could get Python handling lots of connections and making lots of cores hot. And it was a pain to write. It was fun to write, but a pain to write. And while publishing that, it was pre-1.0, I came across Go, and I was like, oh my God, all these things I've been banging my head against in Python are just solved at the language and runtime layer. So I was very much a fan of Go from the very first time I saw it. I've also had a long time interest in AI. So in high school, I was neglecting some of my math homework and studying perceptrons. I was also doing like genetic algorithms and artificial life stuff. So just long time interest in the topics in the space. It was very much in winter in terms of AI research. It does warm me to see MLP mentioned in modern model architectures. So that's multi-layer perceptron for those that don't know. And that little component, while a lot has changed, that little component has kind of remained throughout that time, which is nice to see. So what gives me any credence to talk about any of this? I've been very active in the San Francisco generative AI space. It's almost refreshing here to not have everyone talk about AI all the time. It's sometimes you'll go to a house party in San Francisco and there'll be a placard on the wall that says "No AI talk." So thank you for not talking about AI. Leave it to me for now. So professionally, I've been working more on the ML ops side of the house, but I have been assisting teams in model development. I haven't done a ton of model development myself, but I've been assisting teams that have been doing model development. And in my latest role, I'm in like a MLOps dev tooling space. So it all fits very well. And I mentioned Go fan at the bottom there. I want to mention I'm a the game fan as well as Go, the programming language. And funny enough, the reason why I got so interested in Go, the game, very early on, was that I knew that, at least at the time, it was unsolved in terms of machines besting humans. If you know AlphaGo, the system, or the documentary, you know that's changed since then. But fun fact. OK, so high level, what is the state of the generative AI ecosystem? So I'm going to start going very much like industry, how the VC ecosystem's thinking about things, to some of the startups that are in the space. And I promise I won't spend too much time on that, and we'll get to Go code pretty quickly. But really high level, the general thing you can understand from this slide here is that average spend in this by a small set of companies sampled, is already fairly high and is going up. So I know there's a lot of criticism of the AI space as this is just a flash in the pan, it's a total fad. While of course the hype cycles exist, there's going to continue to be a lot of investment in this space. In terms of the major purveyors of models, sorry, Google, if you're in the room, you're number 2 right now. So unsurprisingly, I'm sure many of you have used ChatGPT, at least the consumer product. Perhaps some have used the hosted models. That's currently the dominant actor in the space. But you see this interesting tail. Related to that, I should point out, it says llama there. Meta doesn't, at least today, they don't offer models, but it is interesting to see that there's an open model in the ecosystem here. And then this slide is interesting in that basically only 18% of, again, biased sampled company set, do not plan to leverage open source AI, which perhaps I should say open weights. We can debate about how that label is used. But I think this is really interesting in that there's general interest in open source technologies being heavily involved with how companies are applying AI. And there's expectation that that will increase over time. So that's very high level on kind of some of the economics at play. What does the stack look like? So by stack here, I mean, what are the companies and tools and technologies that are being adopted in those companies where, in many companies, but including those that are increasing their spend. So I'm going to source from Sequoia here, which, if you're not familiar, is a well-known VC firm in the Bay Area. And sometimes these maps can be a little silly. I think this one's well done. But we're all Go programmers here. I'm sure you've seen the CNCF maps that are, have like 700 plus companies on them. It's not that bad yet. It's getting there. But the thing I want to point out here is the logo may be a little familiar from this morning, but in Sequoia's published map, the kind of premier dev tool infra offering is LangChain, and I put a green arrow on LangSmith as well because that's actually a product made by the company backing LangChain. I've been saying LangChain. What the heck is LangChain? LangChain is a company, but it's also an open source project. And just disclaimer, my project, LangChainGo, is not affiliated with LangChain, the company. So I do not work for LangChain. And what is LangChain does a lot of things. I'm not going to explain each of these nodes around the ring here in great detail, but at a high level, you can see it as an open source library or framework that makes it easier to build generative AI applications, tools, products. There's a wider ecosystem around LangChain. We're not going to be concerned about very much of it, but just to kind of contextualize things, LangSmith, as I mentioned, is up here at the top. It's the LangChain company's kind of observability offering. You can think of it as kind of a trace viewer. It's not OTel-based, but trace viewer, that's closed source, commercial offering. As an open source hacker and contributor, I'm not so interested in that. I'm more interested in zooming into the core component here, where the LangChain and LangChain community projects sit. So you might squint a little, but the two languages mentioned over there are Python and JavaScript. So LangChain proper does not have a Go implementation. The only languages that they implement are Python and JavaScript. So cribbing from Cameron, there's Cameron. Thank you for letting me crib this slide. So I think it's really interesting to think about what's happening in the ecosystem with regard to what languages are emerging as predominant around generative AI. And it's certainly the case that LangChain as a company, and I'll speak to some other vendors down the line, if you look at what they're going to market with, they have the Python SDK, they have the TypeScript or JavaScript SDK out of the gate, but the Go SDKs sometimes come, but they're usually not not there out of the gate. And I think this presents a tremendous opportunity for all of us and for the Go language more broadly. So where does LangChainGo fit in? Basically, we're going to be the Go implementation of these core libraries that are open source and free, liberally licensed, and going to make it so that the techniques that LangChain allows any Python or JavaScript developer apply, we also have the opportunity to apply as Go developers. So that brings me to LangChainGo. So when just a little bit of background, like the reason why I wrote it, or why I thought to write it, was actually when I saw that LangChain JavaScript was first announced. When I realized that, oh, Python is obviously racing ahead, as someone that used to deploy Python in production for many years, and that experience is part of what drove me to Go. Cameron talked about some of the obvious benefits. I'm sure a lot of folks in the room are familiar with trying to run Python runtimes at any appreciable scale in production. We should get a beer later and tell some more stories. When I saw the JavaScript version drop, I was like, oh, wow. Maybe there's an opportunity for other languages to get involved here. And I jumped in and sat down and converted some of the core concepts. I tried to be diligent with regard to what got brought over. I didn't want to do a direct port. I unfortunately didn't attend the Java to Go talk. I presume part of the messaging there was like, don't just apply the same patterns from another language ecosystem. I very much was adhering to that, in that I intend LangChainGo to remain very idiomatic and to not contain anything more than it really needs. So how's the project going? Pretty good. Like, this is a pretty good growth graph. Would have been nice to get to 4K before this event, but everyone take a moment to add a star right now. I jest, but I would appreciate it. So that's good growth, good star growth. And then we have exactly 100 contributors. Who's going to be 101? Actually, was just chatting with someone who has a PR in the works. So I think we'll be at 101 maybe even before the end of the day today. So I want to touch on a couple of design principles that I've been applying here. I already mentioned being idiomatic and keeping it simple, not one-to-oneing. There's a lot of activity happening around LangChain. It's a very busy, active project. And I don't want to bring everything over. I want LangChainGo to be how you take LangChain concepts and put them into a production quality application deployment service. And that means not porting everything over. So 80-20 rule applies. Let's make sure that the things that we implement in LangChainGo are actually valuable and are not just extra lines of code. OK, I've been yammering on. What does it actually look like to use LangChainGo? Let's look at some actual Go code. So this is kind of the shortest example without ignoring errors. I will ignore some errors in later slides. Let's hope that goes well. Short example without ignoring errors. So TLDR, we are initializing a model. We're using OpenAI here. I'm going to demonstrate how easy it is to not just use a different hosted model, but we'll also do some on-laptop inference. So Olama was mentioned in Cameron's talk this morning, and if you attended Johnny's workshop, there was some Olama in the mix as well. I'll talk a little bit more about Olama in a moment. OK, so let's drum roll this. I did have to hack up the present tool a little to get this working. Oh, no. Demo gods. I could ask ChatGPT how to fix the issue, yeah. So let me come right back. We're going to make this work. Give this another go. OK, compile time, generating. So if you've done any, I know the number of hands around how many people have worked with models was not super high, but something you'll come to realize is that we're I/O bound again, and that tokens do take a while to come along here. OK, so that's kind of a very short amount of like very basic intro. But as I mentioned, streaming tokens is very relevant. We're Go programmers. We don't let our context time out. We're gonna do things in streaming fashion. I have to look at the monitor, which is a little annoying, but we'll get there. OK, so this is a slightly more complex example. Instead of just, I used a high level, like generate from single prompt helper. This is kind of more typical with regard to what you'll see in examples. And we're only constructing a single text part here, but we're saying it's coming from the user. That's what chat message type human refers to. And then here we have an option where we pass in a function that gets every chunk from the inference output. So there we go. Hello, GopherCon Europe. And we can actually hop in here and I know Matt's a little wittier than I am, but let's see if we can get the model to emulate his behavior. I hope it's really corny. Let's see what we get. Why do gophers get lost? Because they always follow the path package. OK. I think Matt would have done a little better in person. OK, so this example here exited quickly. This shows how I'm going to swap back and forth here. It's basically the same thing. This is swapping out the commented lines. This shows you how easy it is to go to a different inference provider, in this case, an OLlama provider, which is running the Llama 3 8B model, and that's running locally on my machine. We did get a quick exit earlier, so maybe demo gods are not shining again. But that's OK. We'll move on. I promise it works. So this may help us debug a bit. Small aside here, OLlama itself is also written in Go. I think it's a really cool thing to see. While we don't always get the Go SDKs in the ecosystem first thing, there are growing components that are authored in Go. The slide that Cameron shared earlier showed many other examples. OLlama, I'm actually curious, quick show of hands, who has used OLlama or is familiar with OLlama? OK, seems like about 25% or so. OLlama is absolutely the easiest way to do inference, especially if you are GPU poor. If you don't have a beefy GPU, you can do CPU-only inference. If you have a Mac machine, the Metal backends work quite well. All right, this may tell us, OK, no models loaded, understandable. If we do a direct inference via, I think I let the model become unwarm. So there we go. There's some output. OK. Oops. And then we're at a Google affiliated event. It'd be amiss if we didn't do some Gemini-based output. So here's same program again, but instead of being told hello from the stage by OpenAI, we get Google's Gemini model there. Cool. OK, so really basic code examples there. I'm going to talk about some of the other important capabilities. I'm not going to explain every bit of the ring around the LangChain logo, as I mentioned before, as there's just a lot to talk about. But I'm going to point out some of the most important capabilities. So what you've seen so far is just inference output, which is basically like prompts. And in a real application, those prompts wouldn't all be hard-coded. You would obviously be taking some input from your user and using that to generate some valuable output. Another really important emerging capability, and it's there in almost all providers now, is this notion of structured output. So by structured output, I mean the shape of the inference output is constrained to some contract. In some cases, that only means it's going to be a JSON blob. You see that a lot. In more sophisticated cases, which I'll touch on in a bit, it can be constrained to even more particular output. As a brief aside, not very many hosted providers offer this option, but Llama CPP, which is the inference engine backing OLlama, actually allows you to supply a formal grammar. It's not exactly EBNF. It's GBNF. But basically, you can say, I want my inference output to only sample tokens that are going to satisfy this grammar, which has a lot of really interesting implications. Again, not supported by all hosted model providers. So what do you use structured output for? The most common thing is tool use or tool calling. It's also referred to as function calling. This is where you can take an LLM's output and actually start making it useful. And so what you would do with this is basically you inform the model that here are some possible tools you could call or functions you can call. They're almost always supplied in open API specified format in terms of here are the possible functions to invoke, here are the parameters and their descriptions, et cetera. And then as the inference programmer, you would take that output from the model. It's going to be JSON, right? And you inspect it, carry out the actual calls in your actual system, and then turn around and provide that information back to the model you're calling. And so this is really interesting. And instead of just spewing tokens out into the world, you can take the inference output and have it issue an HTTP request to a service or perform really any action you want, hopefully not involving like RFs locally. As a small example of what that looks like in code, sorry about those omits there. It's pretty straightforward. So just an additional option to the generate content call with tools allows you to supply what possible tools might the model invoke. And this is abbreviated, but again, this is like a Go struct here. We do have some helpers that make it so going from just plain Go code to this format is more tractable. Those are kind of in beta, not out yet, but certainly in our roadmap to make it so you don't have to have a verbose struct defining what possible tools could get called. So demo gods with us. We'll see. I'll have to go back to that OLlama slide. So here's the tool calling example. This is heavily abbreviated, but the basic thing that's happening here is that I issued the request with the option of calling this get weather and location call. And this actually demonstrates parallel tool calling. So the model responded and given our question with two tool calling requests. This is really a great place where Go shines with regard to inference solutions, because parallelizing those calls is trivial in Go. And what we did is we turn around and it's kind of occluded there, but we did these parallel calls to this get weather for location, and then we took the output of those calls and gave it back to the model in the form of a tool call response, and then the model gave us this high-level comparison. So Chicago, slightly cooler and windy. All of this code will be available online, by the way. So this example is directly in the LangChainGo examples. OK, another important capability. So structured output, tool calling, crucial for building like actually useful systems with LLM output. Another important aspect is vector databases. So there's this whole topic of embedding models and embeddings that I don't think I have time to run through today. It is very interesting. Short version is that this allows you to conduct semantic searches. So you can do something like, given some document, some portion of a document, what are other pieces of data you've encountered that are semantically near it. So lots to talk about there. We have good vector database support, and actually from the slide earlier, every one of these vendors we have support for in LangChainGo. OK, I am pushing time a little bit. I'm going to blame the demo gods on that. OK, where are we going in the future? So this slide talks about like the next version of LangChainGo, which is going to be a minor version, but the 0.2 is in development, and I really hope some of the audience steps up and helps me deliver it. So our docs are not great, so we're going to do a doc revamp and refresh. Upstream LangChain, when they went to 0.2, they did some internal cleanups, got rid of some cruft, and we're going to do the same. Thankfully, we didn't bring a whole lot over, but we will clean up some things that we would like to get rid of. Outside the scope of this talk, but there is this kind of a sister project called LangChainGo that I've authored that will be the basis for our new agent implementation. The whole world of agents is almost its own talk. Please come to me after if you'd like to discuss. And then this almost made it in before the talk, but we have, even though it's not it's a commercial thing from LangChain, but we do have support for Langsmith. So that observability tool that they have, we have a good implementation of for LangChainGo. So that will be in shortly. And then we have several open PRs and some work happening around making sure the observability story is just super solid, and I'm excited to get those in too. So there's a little preview of where we're going. So I want to call back to what Cameron was discussing this morning in terms of crossing the chasm. I showed this growth graph, but this is without a lot of context, right? This is the LangChainGo star graph against the Python implementation. So we have some room to grow here. And to that end, I really encourage, it's such an exciting time right now. Go, as many of us know, is a fantastic programming language for building production systems. We're a little behind in the Gen AI space. And yes, it's still very early, but there's a tremendous amount of opportunity, especially if you're not someone that is programming with AI regularly. Getting in and finding a place to contribute, to add a library, to augment a library, to add an example, to add some docs is a fantastic way to get yourself leveled up very quickly and to help the entire Go ecosystem mature with regard to their Gen AI support. So there's some how-tos there, docs, examples, helping out in Discord are all great options. And I'm going to close with basically that appeal to please come help make Go the best. I think it's already getting really good in terms of being a easy-to-use language for writing Gen AI apps. Let's take it the next step and make it so if you want to build real production Gen AI systems, that Go is the natural choice.
Very much.